I would say quantum cascade lasers, as ever, have had a large number of submissions. There's a lot of interesting work, both the science of the devices themselves, extending the range of operation, but also making them more technologically useful, so really driving towards applications, so things like increasing tuning range. I guess there are other areas. VCSELs have attracted quite a few high-quality submissions, and I guess within that there are mode-locked devices. So, and that brings me mode-locked devices, a whole host of submissions on mode-locked devices, both the mechanisms and very good results as well. But certainly there's some very good work on terahertz QCLs. For a number of years now, there's been a limit to the operating temperature of essentially the photon energy divided by Boltzmann's constant. And there's some work this time where they've really worked on the injection process and used a different injection process, and they've actually really broken through that limit. So there's a lot of potential there for moving towards that Peltier-cooled operation for the low terahertz region of operation. There's also some very nice work on tuning mechanisms in terahertz QCLs, and again, driving towards applications, but allowing that tuning even when under cryogenic operation, so making them useful even though they are cryogenically cooled. There is some very interesting work, again, from the VCSEL community, where they're talking about quantum well saturable absorbers with a quantum well active region, and there's been a recent result which is a 60 femtosecond pulse length, and at CLEO we will hear all about the mechanisms that lead to that short pulse length. That's an optical Stark effect mechanism there, and maybe the interaction between the various communities will really generate some buzz at CLEO this year, I think. The terahertz sources are really, as we said, are a really hot topic. There's a fantastic paper on photonic crystal beam steering. In fact, there are a few papers on use of photonic crystals, and that's something that's been evolving over the few years in terms of producing particular output beam patterns. But there's a really great paper on beam steering, plus or minus 30 degrees, all electrically addressable. So that's a really exciting result. There's some work on hybrid silicon active 3.5 devices. Again, that's quite interesting. There's a very nice paper on 2-photon gain in a semiconductor material. In fact, the first time that 2-photon gain's been observed in a solid material. So that is a hot paper. It's also quite a controversial paper, so I think there will be some good audience participation on that one.
Okay.